Everyone, welcome to the channel. In this video, I would be going to discuss about real numbers, Cbse standard 10 mathematics. This video is part 4. In this video, cover root 2 is irrational, root 3 is irrational, 5 minus root 3 is irrational, 3 root 2 is irrational. Get started. Before going to proof and solution, some important notes required for the proof and solution. So first one, if p divides a square, then p divides a, where a is a positive integer. P divides a square, then p divides a. Example, 3 divides 27 square, 3 divides 27. Theory by contradiction. At a time, only statement or opposite statement is true. Either statement or opposite statement is true. If statement is true, then opposite statement is false. And opposite statement true, then statement is false. At a time, only statement is or opposite statement is true. Statement x is positive integer, opposite statement x is negative integer. If x is positive integer is true, then x is negative integer is false. If x is negative integer is true, then x is positive integer is false. Coprime. If two numbers have no common factor except one is coprime. 9 factors 1 into 3 into 3. 14 1 into 2 into 7. 1 is common factor of both 9 and 14. 9 and 40 is coprime. 12 1 into 2 into 2 into 3. In 9 and 12, 3 is the common factor. So 9 and 12 is not coprime. In fraction, divide both numerator and denominator by highest common factor of numerator and denominator. Then the fraction is coprime fraction. 15 non-coprime fraction to coprime fraction. Divide highest common factor of numerator and denominator in both numerator and denominator. 15 by 25, 5 is the highest common factor of 15 and 25. Divide 5 in both numerator and denominator. 3 upon 5. 3 and 5 is now coprime. 15, 25 is not coprime. Divide highest common factor of numerator and denominator. Then get 3 upon 5. 3 upon 5 is coprime. Start. Root 2 is irrational. So this theorem proved by using theory by contradiction. First contradictory statement. Let us assume that root 2 is rational. If root 2 is rational, root 2 can be written in the form of p upon q r by s. Suppose r and s is not coprime. Divide highest common factor of r and s in both numerator and denominator. Now get root 2 is equal to a upon b, where a and b are coprime. Equation 1. Then transpose b root 2 is equal to a, squaring on both sides. B root 2 whole square is equal to a square. Square and square root cancel. Then 2b square is equal to a square. Left hand side 2, right hand side a square. Means 2 divides a square and also divides a. If p divides a square, then p divides a. This is example like 2 divides a square and also divides a. So 2 is the factor of a. Then a can return. Multiple of 2 is 2c. Put equation 2. Left hand side 2b square. Right hand side instead of a 2c whole square. 2 square is equal to 4c square. 4 divided by 2 is equal to 2c square. Now, right hand side 2, left hand side b square. So 2b square is equal to 2c square. Right hand side 2, left hand side b square. So 2 divides b square and also 2 divides b. So equation 1 gives where a and b are coprime, no common factor except 1. But 3 and 4 gives 2 is the common factor of both a and b. 1 gives a and b have no common factor except 1, but 3 and 4 gives a and b have common factor 2. This is contradictory due to wrong assumption since root 2 is irrational. One says a and b have no common factor except 1, but 3 and 4 gives 2 is the common factor of both a and b. This is contradictory due to wrong assumption since root 2 is irrational. Next, root 3 is irrational. Root 3 is irrational, proved by theory by contradictory. Same method of root 2. Wherever 2 will come, put 3. If root 5 is rational, same method. Wherever 2 will come, put 5. So root 3 is rational, same method. Let's assume that root 3 is rational. Root 3 is equal to r upon s. Suppose r and s is not coprime. Divide highest common factor of r and s in both numerator and denominator. Now root 3 is equal to a upon b, where a and b are coprime. 1. Transpose b root 3 is equal to a. Squaring on both sides. B root 3 square is equal to a square. Square root cancel. 3b square is equal to a square. Equation 2. 3 divides a square and also divides a. Now a is equal to 3 into c. Put equation 2. 3b square is equal to 3c whole square. 3 square 9. 9 by 3, 3. B square is equal to 3c square. Now 3 divides b square is equal to 3c square. Right hand side 3. Left hand side b square. 3 divides b square and also divides b. 1 gives a and b have no common factor except 1. But 3 and 4 gives a and b have common factor 3. This is contradictory due to wrong assumption since root 3 is rational. Example 10. Show that 5 minus root 3 is irrational. So here method is one side cube irrational number and right another side is irrational part. Left hand one side keep irrational part, another side is rational part. Let's assume that 5 minus root 3 is rational. Then 5 minus root 3 a upon b, a and b is coprime. Here left hand side rational 5 transpose to right hand side. 5 minus a upon b root 3. Since a and b are integers, 5 minus a upon b is rational and so root 3 is irrational. But this is contradictory the fact that 5 minus root 3 is rational. Left hand side rational, right hand side irrational. Root 3 is irrational. 5 minus a upon b rational. This is contradictory due to wrong assumption. Example 11. Show that 3 root 2 is irrational. This also same method. One side keep irrational number, another side rational number. Let's assume that 3 root 2 is rational. 3 root 2 is equal to a upon b, a and b is coprime, b not equal to 0. Now transpose 3 to right hand side. A upon 3b is equal to root 2. Since a and b are integers, a upon 3b is rational and so root 2 is irrational. But this is contradict the fact that 3 root 2 is rational. So here over this part. Thank you for watching.